Perfect. I think we're good. Is my screen visible again?
Yes, it is.
Perfect. Let's get started. So I'm gonna revert to the first version of your notebook and we are quickly going to go over and reiterate the law of averages. This has been covered in class essentially, like in I have a very interesting simulation over here which will help you understand this better. Essentially लॉ ऑफ एवरेजेस को आगे जाके हम reiterate करेंगे when we cover bootstrap sampling. Bootstrap sampling leverages this law. So let's recall the Monty Hall problem. Suppose you're on a game show and you're given a choice of three doors. Behind one door is a car, and behind the other two, there are goats. Now, suppose you pick door number one, you will pick one door, and then the host, who knows what is behind each of the three doors, will open one of the two remaining doors, and the host will always open a door behind which there is a goat. So essentially, in terms of probability, this means कि जो door आपने pick किया था initially, उसके पीछे car होने की probability was 1 by 3. And the probability, the combined probability of the car being behind one of the other two remaining doors was 2 over 3. जब host ने उन two doors में से एक open कर दिया जिसके पीछे गोट थी, तो this means that the probability that the car is behind the other door that the host has not opened is 2 by 3, and the door that was your choice uske piche car hone ki probability is still 1 over 3. So the question is कि does shifting your door improve your chances of winning? And the answer, like we visited in class, is yes. Since if you shift your door, you have a 2 by 3 chance of winning. But if you stick to your door, then you only have a one-third chance of winning. This may not be evident if this chance experiment is repeated two, three, four, or 10 times. But the more number of times you repeat it, the more your probability will reach the theoretical probability. And that is what the law of averages tells you. If a chance experiment is repeated many times independently and under the same conditions, then the proportion of time that an event occurs gets closer to the theoretical probability of the event. If you increase the number of rolls of a die, the proportion of times you see the face with 5 spots gets closer to 1 by 6. Similarly, if you were to toss a coin 10 times, it is possible कि 8 out of 10 times आपको head मिले, but that doesn't mean कि head आने की probability is 80%. The theoretical probability of obtaining a head is 50%. Now, if I repeat that same experiment 100 times, so it's possible that you get a head 60 out of 100 times. And then if you repeat it 1000 times, it's possible that 505 times out of 1000 आपको head मिले. So as I increase the number of times the experiment is repeated, the observation is reaching what your theoretical probability was, या theoretical estimate जो था आपका. And here we have a simulation of exactly this. I would encourage you to try this out on your own as well. Abhi, we will see that in this problem, you have selected the number of trials. See, you have this interactive available over here. ये आपके पास available है board, and I've selected 10 right now. The red line in bold highlights the strategy where you stick to the original door of your choosing, in which case your probability of winning should be 1 over 3, your theoretical probability of winning. The blue line in bold represents that you are switching, in which case your theoretical probability of winning should be 2 over 3. Y axis के ऊपर आपके पास probability है, and x axis के ऊपर you have the number of trials. We will not go over the code. It is not important for you. If I increase the number of trials, oh, initially we'll see कि जब आपने सिर्फ one trial किया, तो blue line के ऊपर you have the probability as 1, red के ऊपर you have it as 0 because ultimately either the person won or the person lost. However, if you keep repeating these experiments, तो ये chance probability इस तरह increase करती जाती है. Now you will observe कि eventually, see, this is the value that I'm reaching, 0.677. This is the value that I'm reaching over here so far, 0.32. The theoretical probability should be 67% and
Uh, hello?
33%. Yes, Sarish.
Are you showing something on the screen?
100%, can't you see it?
No.
This entire time?
Yeah, no. I thought you were just okay.
Oh my. Can you see my screen now?
Yeah. Yeah, yeah.
Okay, perfect. Well, I hope you were listening though. So I'm just
Yes,
gonna
yes.
show you कि ये हमारे पास कोड है, इससे हमने ये जनरेट की है. All right. So now you can look at the
Okay.
red line, the blue line. The stick strategy, stick to your door, and the switch strategy, switch your door. इस बार को यूज करके if I keep increasing the number of trials, तो ये probability यहाँ पे आ जाती है 67%, 32%. If I increase it even further, like अब ये 3000 से ज़्यादा trials हो गए हैं, तो 66.7% and 33.3%. Exactly what the theoretical probability was. Are there any questions so far? Okay, do try it out later. For now, I am going to revert to the next version of this notebook. And we are going to go over a topic that is very deep conceptually and very important. इसकी हम एक practice problem देखेंगे and we will look at one notebook first, which will help us gain a little clarity. You have already covered this problem in class. We're going to look at assessing models and we're going to look at hypothesis testing through the example of Gregor Mendel's P-flower model. I have this somewhere around here as well. So, okay, perfect. So, to do a quick recap, this was the guy. He was an Austrian monk who is widely recognized as the founder of modern genetics. He performed careful and large scale experiments to come up with the fundamental laws of genetics. Anyway, let's go over Mendel's model of pea flowers. Pea flowers के अंदर you had two different colors of flowers, either purple or white. Mendel's model of pea flowers made one simple claim that the probability that any plant will have purple flowers is 75%, and the probability that any plant will have white flowers is, well, 1 minus 0.75, 25%. This was his model. Yeah, here we go. Each plant is purple flowering with a chance of 75%, regardless of the colors of the other plants. And now we want to assess his model. We want to run a statistical test. So I will give you a recap of the important steps in assessing a model. You should know how this works. First of all, you come up with a statistic that helps you decide whether your data is supporting the model or an alternative view of the world. And how do you choose a statistic? You choose a statistic in such a way. Actually, let me show you here as well. Yeah, test statistic. A test statistic helps you decide between two hypotheses, a null hypothesis and an alternative. A null hypothesis assumes no effect. An alternative hypothesis assumes some effect. What you have to be careful about when choosing this statistic is, well, you need to know what values of the statistic will make you lean towards the null hypothesis and what values will make you lean towards the alternative. Alternative may your answer should typically just be high. For instance, actually we haven't covered alpha beta testing yet, so I am going to put a pin in that. ठीक है, once you decide a statistic, उसके बाद you have to simulate the statistic under the assumptions of the model. And then you draw a histogram of these simulated values. जो आपके पास distribution आती है as a result, this is the empirical distribution of the statistic. Once you have this distribution, then you look at the observed value of your statistic. So, जो आपने histogram बनाया है, that is under the null distribution. Then you look at the alternative, then you look at the observed statistic and see if you have enough evidence to reject the null hypothesis. If you don't have enough evidence to reject the null hypothesis, you don't accept the alternative, you simply fail to reject the null. You either have evidence against the model or you have evidence in favor of the model. डिटेल में हम इसको through an example देखेंगे. So this is the statistic that we are choosing. Proportion of purple white flowering plants minus 0.75, and then you take the modulus of that. So modulus से essentially आपके पास क्या आता है? You know the distance from 75%. You get to understand the difference from the 75% value that was proposed by the model. If this distance is closer to zero, so here you will reject the null hypothesis. Otherwise, you will fail to reject it. So I will quickly walk you over the code. You define an array containing one white and three purple plants. This is how we've done so. And then you have a simple function जो आपको test statistic की value calculate करके देता है by counting the number of purple flowers in your sample. Sample is an array that is passed and then it divides it by the length of the sample. जब ये proportion आ जाती है तो ये उसका absolute distance लेता है from 75% and it returns that to you. You have to repeat this for multiple samples several times in order to generate a distribution. In this case, we are doing this experiment for 929 plants and we are repeating this experiment 1000 times. I will elaborate a little on that as well. So अगर आपके पास 929 plants हैं तो आप उन सब plants के लिए एक distribution generate करते हैं using this rule. The rule is that there is a 75% chance, a 3 by 4th chance that the flower is going to be purple. And there's a 25% chance that the flower of this plant is going to be white. So, using this rule, you generate a distribution. You do this once for 929 values. आप 929 plants के लिए ये values generate करते हैं. It's like if I had a die, I would roll it 929 times, and then I would record the number of times I obtain a certain number. So, इसमें you have this many plants, you record the number of plants जिन के flowers were purple. Then you compute the test statistic for that sample. इस तरह के 929 plants के आप random samples 1000 times लेते हैं in order to generate a distribution. Let's put a pin in the observed statistic. First, I want to show you where we have repeated this experiment to generate a distribution. Also, that's my bad. We didn't do it 1000 times, we did it 10,000 times. So, in the range of repetitions, you make a random choice from the total plants. And total plants ke andar you had three purple plants and one white plant, which means that there's a 75% chance that जो new sample में plant आ रहा है, उसके अंदर you have a purple flower. Anyway, and then you do this 10,000 times and you compute the test statistic. You are saving the test statistic somewhere. Then we are going to plot this distribution. Now I will show you the plot for this distribution.
Hello, the tutorial is being recorded, right?
Yes, 100%. All tutorials are recorded in data science. So ये आपकी null distribution है. Let's try and make a plot real quick. I've just stored the simple array in a data frame. Null distribution or let's simply do dot plot kind equals histogram. And this is what we have obtained. So this is the distribution. Typically, you will see something like this. There's a null curve and there's an alternative curve. We're not going to stress too much on this right now. We'll circle back to this example. Abhi, it feels like I have only half of a curve available. The reason for that being कि मैं absolute value ले रही हूँ statistic की, so it doesn't go in the other direction. Otherwise, it would have been in the other direction as well. Pretty much, it will mimic a normal distribution in that case. So just to show you, okay, this is what your data looks like. Asha, here we are doing exactly the same thing. So this is a neater plot actually. Now I'm going to dial back and tell you what this red line represents. So once you plot your null distribution, which you have simulated under the null hypothesis, उसके बाद you make a line and you mark the value of the observed statistic. Because what we have done right now is कि हमने rule define कर लिया based on the model's assumption एंड उस रूल को यूज करके हमने एक डिस्ट्रीब्यूशन जनरेट कर ली दिस डिस्ट्रीब्यूशन इज कॉल्ड द नल हाइपोथेसिस this null hypothesis ke under the model that was proposed is true we're trying to evaluate कि जो हमारा observed data है does it favor the model the null hypothesis or does it favor an alternative view of the world मतलब does it reject the null hypothesis so in order to do that what we did was कि we took the model's assumptions and we used it to generate the data under the null distribution. I am repeating this every now and again because often these concepts are a bit daunting at first. So ये आपके पास null distribution आ गई and then you look at your observed statistic as we have over here. Observed statistic वो है जो हमने खुद नहीं compute किया वो हमारे पास ऑलरेडी अवेलेबल है फ्रॉम नेचुरल डेटा दैट वाज अवेलेबल टू अस अभी जो हमने डेटा लिया है वो हमने खुद जनरेट किया है अंडर द assumptions ऑफ द मॉडल यू कैन जनरेट डेटा वी हैव डेटा जनरेटिंग algorithms and all so abhi we have simulated data we have made this data ourselves then there is an actual value that is available from nature so for instance George Mendel this guy उसने एक actual value observe की होगी for an actual number of plants in nature suppose they were 929 plants they actually were 929 plants so उन plants के लिए जो उसने actual value observe की थी in nature in a natural experiment वो वैल्यू हम लेते हैं एंड उस वैल्यू को हम प्लॉट करते हैं ऑन टॉप ऑफ आवर नल डिस्ट्रीब्यूशन then we are able to observe whether this value favors the model or whether it does not favor the model. Are there any questions up until this point? Okay, I will show you how we compare this value with the histogram now. So ये वाली value जो है, I'm coming back to this now. This is called the observed test statistic. There were a total of 929 plants that Mendel grew himself. So he conducted this experiment. उन plants के लिए उसने जब यही test statistic calculate की जो हमने define की है this is our test statistic so the value he obtained was 0.008805 this is the observed statistic we have not simulated this we have not synthetically generated this we have observed it then I plot the value over here and what does this tell me well, as of now, it doesn't tell me anything. Now, either based on this value, I will reject the null hypothesis, which means that I will reject his model, or I will fail to reject his model. Alternative ko, I cannot accept that. I can either reject the null or I can fail to reject the null. But in order to do that, you have to have a certain predefined threshold, right? यहाँ पे ये value 0.08 है, just a little behind 0.01. Sorry, 0.008, my bad. I could say कि suppose if the value is greater than 0.02, then you can fail to reject, sorry, then you can reject the null hypothesis. अगर इससे पीछे है value, तो in that case you will fail to reject the null hypothesis. But of course, I have to define this threshold. So the threshold that you define on your graph is called the critical value. Now we are going to dive deeper into all of these terminologies that you have been over. And I suppose कि इस image को यहाँ पे ले लेते हैं so that we are a little bit more clear about this. So what I'm saying is कि you have to have a certain threshold defined. Otherwise, how will you determine कि इस value का क्या मतलब है? Suppose कि मैंने वो threshold green line से mark कर दिया है. My threshold is 0.02. Now, according to my test statistic, which was, let's see, this was my test statistic. The proportion of purple flowering plants minus 0.75 का modulus. So under the null hypothesis मुझे क्या value मिलनी चाहिए test statistic की? Very close to zero, right? Under the null hypothesis, I am favoring Mendel's model. So that means कि under the null hypothesis ये value zero के close होनी चाहिए, which means closer to this side. So if I'm defining a certain threshold, suppose जो threshold मैंने green line से indicate किया है, I will say कि if that value is towards this side of the threshold, then I can reject the null hypothesis क्योंकि ये ज़्यादा distant है from the center of my distribution over here. Alternatively, I will say कि अगर मेरी observed statistic की value इस threshold के left के ऊपर है, तो फिर I will fail to reject my null hypothesis. Are there any questions up until this point? So now I will iterate कि जो ये value आप threshold define करते हैं, this is called the critical value, which has been covered in class as well. So this is the critical value. If your observed test statistic is greater than your critical value, then you will fail to reject the null hypothesis. Sorry, then you will reject the null hypothesis. If your observed test statistic is less than your critical value, then you will fail to reject the null hypothesis. So I will show you this concept of critical value here as well now. इसकी formal definition देख लेते हैं before I show you the significance level. So the critical value is the value of the test statistic at which the probability in the tail of the distribution equals alpha. My bad. First, I have to tell you what alpha means over here as well. So alpha is fairly simple. Alpha is your predetermined threshold k against your value. Yeah, this is your significance level. Significance level. इसका font size increase कर लेते हैं to. So your significance value is, I will highlight this particular region. Since जो मैंने data generate किया है, it is a distribution. So the area under my entire distribution will sum up to 100%. जो region yellow में highlighted है, the percentage of area, this is the percentage of area in the tail of my distribution. This is called my significance level. So if my significance level was suppose 10%, तो 10% के against जो corresponding value आती है, in this case it may or may not be true, that is equal to 0.02. And ये जो corresponding value आती है, that is called your critical. So this is very important. Significance level आप initially खुद define करते हैं prior to your experiment. This is a part of the design of your experiment. You define this yourself. With that, let's go back to our notebook And I will iterate that the critical value is the value of the test statistic at which the probability in the tail of distribution equals alpha. And this is what I will show you over here as well. Either your result is inconsistent with the null distribution or it is consistent with the null distribution. So either the area in the tail is less than 5%, less than 1%, even less than 10%. So ये जो cut off value आप percentage में define करते हैं, this is called alpha. Alpha is the significance level. अल्फा के ऊपर उस सिग्निफिकेंस लेवल के ऊपर जो कॉरेस्पॉन्डिंग टेस्ट स्टेटिस्टिक की वैल्यू होती है दैट इज कॉल्ड द critical value. So let's go back over here. I haven't defined anything here yet. But now what I will do is there's one last terminology actually. But before covering that, I will define a certain value for this. Let's suppose हम alpha को set कर देते हैं at 10%. I don't know इस ग्राफ में 10% के अगेंस्ट क्या corresponding value आती है, although we can definitely calculate it though. We're not going to do that right now. We don't need to do it for this experiment. I will definitely show you in the next example. So suppose this was my significance level. Against this, suppose that my critical value, like we saw, is 0.02. So ये मैंने set कर लिया है threshold. Now this red line, which is representing my observed statistic, is equal to 0.00088. I think there were three eights. Anyway, इसको हम replace कर देते हैं significance level से because it will make more sense to you then. Now observe test statistic के against you will have your observed significance level. This we will need to compute and I will tell you what this essentially means. अभी जो region yellow में highlighted है, the percentage of region ahead of my critical value is my significance level. ये predefined था. So जो exactly threshold था वो ये था and then the observed significance level will be the area that is in this region of your graph essentially मतलब all the area जो आपके observed statistic के right के ऊपर है, which is why we call it the observed significance level. You should be able to differentiate between these two terminologies for that matter as well. So इसको compute करना is fairly simple क्योंकि I have a distribution over here. I just computed this for like 10,000 different values. उन 10,000 values में से अगर मैं compute कर लूँ कि कितनी values के लिए the test statistic was greater than or equal to the value over here in red, so I will essentially be able to compute this area. I mean, I have to take the proportion against the total number of times that this experiment was repeated. We will not go over p-value right now. I just want to show you this idea that we've just discussed. Sample stats greater than or equal to observed statistic. ये चीज मुझे ट्रू या फॉल्स रिटर्न करेगी. मैं ट्रू का काउंट डिटरमिन कर रही हूँ. This is an NP function. I count the non-zero values returned over here and then I divide it by the total number of repetitions, which was 10,000. So this gives me 54.59%. Essentially what that means is कि ये जो area मैंने yellow में highlight किया है, that area is 54%. 54 point whatever percent, and my significance level was 10%. So जो अभी मैंने value compute की है, this is my observed significance level, and your observed significance level is what your p-value is. So often the definition of p-value is confusing for students. Just remember the root of it, where it stems from. I will show you the formal definition now. The p-value is the chance under the null hypothesis. Under the null hypothesis means that you assume the null to be true, that the test statistic is equal to the value that was observed in the data or is even further in the direction of the alternative. इसको हम मजीद break down करें तो you can say that it is the chance under the null hypothesis that the test statistic is greater than or equal to the value observed. Are there any questions up until this point? So now I will encourage you guys to pause and think over here for a few seconds. The significance level that we set was 10%. The observed significance level is 54.59%. Does this mean that we will reject the null hypothesis or will we fail to reject the null hypothesis? If we have anyone here still, I would love for you to volunteer a solution as well. But for those of you watching, please make sure to pause and think. So essentially, since we set the significance level to 10%, you will fail to reject the null hypothesis. If we break it down in very simple words, so I will just say, okay, look at where this red line is and look at where this green line is. हमारी observed value इससे पीछे है. Whenever this happens, you fail to reject the null hypothesis. You know, it's closer to zero right now. If this was ahead of the green line, then you would have failed to reject the null hypothesis. So what we're looking for is you check the p-value and you check the significance level. If the p-value is greater than the significance level, then you will fail to reject the null hypothesis. If not, you will reject it. Are there any questions up until this point? Okay, we're going to move on towards our practice question, but I'm gonna pause over here for a minute on account of the azan. I will give you guys some time to go through this setup meanwhile, though. All right, let's go over our question. A study evaluates the effects of a new sleep enhancing therapy to improve sleep quality in adults. Like I've mentioned before, I will reiterate that the null hypothesis always represents no effect. The alternative hypothesis represents an alternative view of the world where there is an effect. So, you should be able to tell as well. The null hypothesis would be that the new sleep therapy has no effect on sleep quality. The alternative hypothesis would be that the new sleep therapy improves sleep quality, as simple as that. The mean sleep quality index of results. Oh, yeah, of course, I will iterate this as well. And with that, I will quickly go over alpha beta testing as well, permutation tests. So the mean sleep quality index of results that of sorry adults that are receiving the therapy is pretty much same as the general population, which means whether that therapy is given or not makes no difference at all. If you calculate the mean sleep quality, you will find that it is the same for both. If you calculate the difference in means, you will find that it is zero. And then alternative hypothesis में the mean sleep quality index of results, sorry, of adults receiving the therapy is higher than that of the general population. So if you were to compute the sleep quality index, you will see that it is higher in adults that are receiving the therapy as opposed to the general population, which means that the difference in means is zero. And I keep saying difference in means because this is the test statistic that we will be using. Let's recall कि आप जो टेस्ट स्टेटिस्टिक डिफाइन करते हैं, you will I will just go over to it once more because this is important. Yeah, the test statistic that you choose to simulate to decide between the two hypotheses uh, must be chosen in such a way that preferably high values of the statistic will make you lean towards the alternative. I will choose difference in means right now. मैं दोनों groups का mean compute करूंगी. And so let's see. Mean of group receiving therapy minus mean of group not receiving therapy. If I compute this statistic, so under the null hypothesis H naught, the difference in these means would be, इसको हम actually let's make it simple. Mean A कह देते हैं and we'll call this one mean of group B. So the null hypothesis will state that the mean A minus mean B is equal to 0. ये मेरी test statistic है. Alternatively, the null hypothesis will state that mean A equals mean B, which I'm just getting by rearranging the equations. My alternative hypothesis will state that the mean A minus mean B is, well, I want कि इस group का mean ज़्यादा हो, तो this must be greater than 0. Or mean A is greater than mean B. This means that this test statistic works very well for me because high values of the statistic, greater than 0, the higher they are, the more they will make me lean towards the alternative hypothesis. And the closer they are to 0, the more they will make me lean towards the null hypothesis. Are there any questions up until this point? With that, I will quickly go over what a permutation test is. It's been covered. I will just reiterate this one example. So you have a random sample of mothers and of newborns. What were you trying to determine? Yeah, you are trying to determine whether if a mother smokes or not is correlated with the weight of the baby. So what you want to see is okay, the mean weight of babies in mothers that are smoking, whether it is typically smaller than the mean weight of babies in a population of mothers that were not smoking. So अगर मैं इन दोनों ग्रुप्स का डिफरेंस इन मीन्स ले लूं तो आई कैन से कि वो डिफरेंस इन मीन्स की वैल्यू जितनी क्लोजर टू जीरो होगी, that would make me favor the null hypothesis. That would tell me that there is no effect of, mother smoking on the weight of the baby. And the higher that this value is, the more it will make me lean towards the alternative. The more it will tell me, okay, this does have an effect on the weight of the babies. In order to do so, I have two groups. I have group A and I have group B. Like I've mentioned over here, group A may you have the baby weights of babies of mothers who smoked during pregnancy, and group B may you have the weights of babies whose mothers did not smoke when they were expecting them. But will it suffice कि मैं ये दोनों groups लूं और इनका difference compute कर लूं means में? I will just get one single value of mean. Suppose it was 0.02 kilograms. How do I know if this value is statistically significant or not? I have no null distribution to compare it to. So I will quickly dial back and tell you कि you need to generate a null distribution. But इस case में आप कैसे generate करेंगे? You don't have a very well defined chance model available to you. Mendel के case में, Mendel's model of P flowers, we had a well defined chance model. We were able to use it to algorithmically generate data for us under the null distribution. In this case, we can't do that. You only have these two groups available. So, what you will do is you will run a permutation test. Permutation test assume करता है कि null distribution true होगी. Null hypothesis true होगा and null hypothesis ये था कि इन दोनों ग्रुप्स के मीन्स का डिफरेंस जीरो होना चाहिए. So that is as good as not knowing whether a mother smokes or not when she's expecting the baby. And in that case, we can just shuffle the labels of both of these groups. We can form multiple permutations. So I will show you. Oh, sorry. Okay. Yeah, so I will show you an example of how this works. अभी मेरे पास ये वाला डेटा अवेलेबल है. टी टेस्ट के अंदर आई एम एज्यूमिंग के कोई इफेक्ट नहीं है. एंड इफ आई एज्यूम के कोई इफेक्ट नहीं है तो दिस मीन्स कि मैं इनके लेबल्स को शफल कर सकती हूँ. अगर मैं स्मोकर्स और नॉन स्मोकर्स के लेबल्स को वंस शफल करूँ, then I will be able to compute one single value of the test statistic. Then if I shuffle the labels once again, I will compute a new value of the test statistic. Is there, if I make like 10,000 or 20,000 permutations, so I will be able to make a distribution just like we made a distribution for Mendel's model of P flowers. This distribution will be my null distribution. और ये जो null distribution बनेगी, this is what it will come out to be like. I want you to ignore the curve in red and just look at the curve in blue. This is what my null distribution will come out to be like, and इसका center तो approximately 50 के ऊपर है. जो उस एग्जाम्पल में नल डिस्ट्रीब्यूशन बनेगी उसका सेंटर जीरो के अराउंड होगा. Why zero? Because I'm shifting the label. The difference in means according to the null distribution should be centered around zero right now. So that is how I will make a null distribution. Then I will go back to my original data set, जिसमें I had these two groups available. And इन दोनों ग्रुप्स के डेटा को यूज करके I will compute my observed test statistic. And then everything works exactly the same way that we just saw. You set a significance level, you use it to check the critical value, and then you just check if your critical value is behind the threshold that you have set or if it's ahead of the threshold that you've set. So that we've already covered, but essentially this is a permutation test and it's helping you generate a null distribution. Anyway, that's it about permutation tests. बस आपको पता होना चाहिए how these work, when you use them, why you use them, and of course how you are using them. In this case, we are not essentially using this test statistic, and we are not doing a permutation test. Even if we were, we don't have any data for that available. Uh, Plus, I can tell because your null hypothesis graph is centered around 50. If we assumed कि हमने यही test statistic use की है, then it would have probably been centered around zero. So that doesn't really matter to us right now. Now let's look at all the values that have been plotted for us. We don't know how we have obtained it, but हमारे पास एक null का graph available है, एक null distribution का, and then we have an alternative distribution available as well. That is represented in red. जो green से marked है, that is your critical value, which is 58.22 in this case. I have also given you some probabilities over here. You will be needing them for your math. इसको थोड़ा सा बड़ा कर लेते हैं. Okay, so I've told you X is your test statistic, by the way. In this case, ये नीचे जो sleep quality लिखा हुआ है यही है essentially. So the probability that X is greater than 58, which is your critical value, is 0.05 under the null hypothesis and 0.15 under the alternative hypothesis. ये आपको एरिया बता रहा है एग्जैक्टली उस ग्राफ के अंडर. सिमिलरली मैंने आपको 58 के लिए दे दिया एंड मैंने आपको 60 के लिए दे दिया. यू डोंट नो व्हाट 60 इज राइट नाउ, बट आई विल टेल यू कि इवेंचुअली एक पार्ट में we'll see कि 60 is what our observed statistic is. We haven't plotted it right now. So the first question is, what is, oh, hold on. एक question हमारा चला गया. What is the significance level alpha? I want you guys to pause over here and think for a few seconds. ये आप कैसे determine करेंगे? You will use the graph that is given to you and you will use the table that is given to you. Okay, so now I will comment on this. And before that, let's quickly recall कि significance level क्या था. You check the critical value. Critical value के right side के ऊपर जितना area होता है under your null distribution, that is your significance level. And my critical value is 0.58. The probability that my test statistic is greater than my critical value under the null hypothesis is 0.05. Essentially, this means that my alpha is equal to 5% or 0.05. Are there any questions? Okay. Next, you are told to calculate the p-value. P-value is also called your observed significance level. If the observed test statistic is 60, अब 60 इसके ऊपर plotted नहीं है, but I do have the curve right here. So we could quickly plot it though. So in red, I have plotted the observed significance level. Sorry, not observed significance level. मैंने observed test statistic plot की है. You have to find the observed significance level. So I will go back to the graph and you will be using the values in the table to compute this. I encourage you to pause and think. So your observed significance level is the value that is to the right of your observed statistic under the null hypothesis curve, which means that the probability that x is greater than 60 under the null hypothesis. Essentially, this is the area that I'm trying to find. I will highlight this here. Oh, my bad, मैंने ज़्यादा highlight कर दिया. This is what I'm trying to find. अब ये essentially क्या है? This is the area under my blue curve, which is my null hypothesis curve. This is the area under the null distribution that is greater than the observed test statistic. This is the observed significance level. And ये value आपको given है 0.03. So this is equal to 3%. Are there any questions up until this point? Okay, let's look at the next one. So this is fairly simple. Would you reject the null hypothesis? I will encourage you to pause and think once more. So essentially, जो observed test statistic की value है, it is greater than the critical value. It is in this particular region. It is in the region to the right of your critical value. This means that you will reject the null hypothesis. अगर ये इसके left पे होती तो you would fail to reject the null hypothesis. It would be closer to the center of your null distribution, which is around 50. So let's go back here and you will reject the null. इसकी आपके पास explanation भी होनी चाहिए. You reject the null because the p-value is less than alpha. This you should know. The p-value is less than alpha. That is why you reject the null. Next, you have to estimate the power of this study. And that's another important concept that I want to reiterate over here. But before we do that, I just want to quickly tell you about type 1 and type 2 errors. Because your conclusion could be wrong at the end of the day as well. Either the null is true or the alternative is true. If your test rejects the null, even though the null was true, so that is a type 1 error. If your test does not reject the null, even though the alternative was true, that is a type 2 error. You should be able to differentiate between the two. So टाइप 1 एरर एंड टाइप 2 एरर के रीजंस को भी हम हाईलाइट करके समझने की कोशिश करते हैं. अब मैं ऑब्जर्व वैल्यू हटा रही हूँ अपने ग्राफ से. आई डोंट नो द ऑब्जर्व वैल्यू राइट नाउ. आई डू नो व्हाट ए टाइप 1 एरर इज though. We will connect all of these together by the end. So a type 1 error is, oh my bad, failing to reject the null even though it is, oh again मैंने type 2 error का लिख दिया. So let me just correct this. Rejecting the null hypothesis even though it is true. Let's try to identify the area that represents a type 1 error. We can just do this over here. So you reject the null even though it is true. Let's recall. You can completely ignore the curve in red क्योंकि हमने ये चीज specify कर दिया. Even though it is true, we know that the null hypothesis is true. Assuming that the null is true means कि आप सिर्फ blue वाले curve को देखेंगे. When will you reject the null hypothesis? जब test statistic की value इस region में आती है, when it's greater than the significance level. Our significance level was 5% if I'm not wrong. Let's double check as well. Yeah, हमारा level 5% था. So it means ke there is a 5% chance that I will have a value in this region. And of course, there is a 95% chance that I will have a value in this region. So what is the probability of type 1 error? I will encourage you to pause and think. The probability of a type 1 error is simply 5%. If the null is true, so there is a 5% chance that I will still reject the null hypothesis just because the value of the observed statistic was greater than the critical value. Are there any questions up until this point? So there is a 5% chance. What if I want to decrease these chances? What will I do? So ये तो बहुत सिंपल है. What I will do is कि मैं इस green line को थोड़ा सा इधर shift कर दूंगी. That should work. If I shift this line a bit here, so of course I will decrease this region. There is an implication of that though. And with that, let's look at what a type 2 error is as well. So type 2 error may what you do is you fail to reject the null hypothesis even though the alternative is true. We don't know कि इसका कितने percent chance है. We will compute this. Anyway, so now you will ignore the the blue curve, and you will focus on the red curve. Focus on it. Why? Because we're assuming that the alternative is true. So हम सिर्फ alternative distribution को देखेंगे. अब alternative distribution red में highlighted है. When will I fail to reject the null hypothesis? In this particular region. So of course अगर इस green line के critical value के लेफ्ट के ऊपर मेरी ऑब्जर्व्ड स्टेटिस्टिक की वैल्यू आती है इफ इट इज इन दिस येलो रीजन तो आई विल fail to reject my null hypothesis, right? I will fail to reject it. I am highlighting the area only under the red curve because we are assuming that the alternative is true. So ये जो yellow में area highlighted है, this is the probability of a type 2 error, which is a lot for this particular example. And the value that I'm looking for is the probability that x is less than 58 under the alternative. So let's find this value. Probability that x is greater than 60 under the alternative was 10%, which means कि less than 60 की probability will be 90%. So right now, in my given example, I have a 90% chance of a type 2 error and a 5% chance of a type 1 error. Are there any questions up until this point? This is a very important concept. As long as we have covered that, then we will move on towards power because power ka concept follows next. So we've already covered this part. Let's go over what power is. Power is the power to avoid type 2 errors. So I will just go back to this graph real quick and highlight okay, the probability of a type 2 error was 90% right now, assuming that the alternative is true. So अगर 90% chance है that I will, oh I think I looked at the wrong value, my bad. Wait, मैंने 60 के against देख लिया, मैंने 50 के against देखनी थी, less than 58. So that was 85, not 90%. My bad, I hope this makes sense. You know, I was checking against the critical value, which is 58, it's not 60. So there was an 85% chance of a type 2 error given that the alternative is true. If I know कि type 2 error का ये chance है, तो what are the chances of not having a type 2 error? What are the chances of avoiding a type 2 error given that the alternative is true? I will encourage you to pause and think over here. Then I will highlight that region that we're looking for. And I will repeat myself once. There is an 85% chance of a type 2 error. So, what are the chances of not encountering a type 2 error if the alternative is true? So, you know, अगर वो रीजन येलो में है ऑल्टरनेटिव ट्रू है तो पीछे ये पिंक वाला रीजन बचता है द रीजन टूवर्ड्स द राइट ऑफ योर critical value in your alternative hypothesis curve, which is going to be 1 minus 85%, which means 15%. This is the power of your study. You have 15% power. The power to avoid a type 2 error in this example is just 15%. This is exactly what you are given over here as well. What are the implications of having a low power? So अभी implications इसकी क्या है हमारे पास power बहुत low आई है just 15%. Low power means that you may not be able to find a significant effect even though an effect exists. What if I want to increase my power? What if I want to increase this power? What will I do? If I want to increase the pink region, तो इसका solution भी बहुत simple है. I will take this green line and I will try to move it here. इसको मैं जितना ज़्यादा move करूँगी उतना ज़्यादा ये वाला region increase हो जाएगा. So I will have more power. What is the problem with doing so? Let's recall type 1 error, rejecting the null even though it is true. So the problem is कि इस critical value को मैं जितना पीछे move करूंगी, which means कि जितना ज़्यादा मैं अपना significance level alpha बढ़ाऊंगी, उतनी ज़्यादा power तो increase हो जाएगी, but that will increase the chances of a type 1 error, which I also don't want to do. I have to find a decent balance in between somewhere. I don't want to reject the null if the null is true. So this was one way of increasing power. This method of increasing power essentially involves modifying the design of your study altogether. There are other ways of increasing the power of your study as well, and I will highlight those as well. इस पिंक वाले रीजन को हम पिंक में हाईलाइटेड रहने देते हैं, but I will highlight one other essential area. So ये वाला जो area है, this distance, this is the distance between the centers of the null and the alternative hypothesis curve. And this distance is essentially called the effect size. We are trying to determine this. We're trying to determine कि whether like effect है या नहीं है. नहीं, actually, we're not trying to find the exact effect size. We're just trying to determine whether there is an effect or not. अब वो कितना इफेक्ट होगा वो इफेक्ट साइज बताता है, which is the distance between the centers of these two distributions. So effect size जितना ज्यादा होगा, जितना ज्यादा ये वाला distance होगा, what I will do is कि I will move the red curve to this side, which will increase this distance, right? एंड ग्रीन वाली लाइन एग्जैक्टली वहीं पे रहती है, द क्रिटिकल वैल्यू, बिकॉज वो वैल्यू मैंने प्री डिफाइन, इट वाज प्री डिफाइंड ऑन माय नल हाइपोथेसिस कर्व. सो ये जितना इधर जाएगा, ये पिंक एरिया अब ये सारा हाईलाइट हो जाएगा. सो द लार्जर द इफेक्ट साइज, द मोर द पावर. बट माय क्वेश्चन इज के इज इट पॉसिबल फॉर यू टू इंक्रीज द इफेक्ट साइज? And the answer is no, you don't control this. If you were determining the effect of smoking on cancer, तो आप उसको खुद नहीं control कर सकते. You can try to measure it, but how can you influence it yourself कि कितना effect होगा? You don't get to influence it yourself. All right, there is a third way of increasing the power as well. My curves right now on this graph, null and alternative k, are fairly wide. That is because spread ज़्यादा है मेरे data का. If my curves were narrower, if the spread of my data was lesser, so that would essentially increase the power as well. If this is what my blue curve looked like, and this is what my red curve looked like, so usi value ke against, actually this is getting fairly messy, so I will just show you from the slides now. This I can't do on OneNote. This is how effect size impacts power, and yeah, there you go. अगर आपके curves narrower होंगे तो भी you are going to have more area in this region, which will also increase power, which is essentially what happens when you increase the sample size, because जितना ज़्यादा sample size होगा उतना it is well representative of your original population, and variance आपकी कम होती जाएगी. All right, are there any questions up until this point? Make sure to go through Power Key slides thoroughly as well, and to go over everything that has been covered. There are three things that are influencing power over here: the effect size. The more the effect size, the more the power. And then you have the sample size. The more the sample size, the more the power. And lastly, you have the spread. The more the less the variance of the population, the more the statistical power. With that, let's move on. I have another question over here. This will not take us very long. ये एक past exam का question है. We will make this past paper available to you after this tutorial as well. Make sure to visit it once. So, you are investigating whether background music negatively affects exam performance. To assess this, you conducted an observational study by analyzing the exam scores of two groups of five students with similar characteristics. One group studied with background music, this was your treatment group, and the other group studied without any background music, which was your control group. Each exam score is out of 100 and the scores are as follows. So हमने treatment group के 5 individuals का score record कर लिया and control group के 5 individuals का result record कर लिया. To validate your hypothesis, you conducted a bootstrap analysis. So the reason for including bootstrap sampling is because I want to just quickly reiterate this concept as well. You have bootstrap in here, I believe. Bootstrap sampling is something that you do when you do not have enough data available and when you want to generate a distribution. So if I have like 1000 data points available, and they are not enough. So I can either go and collect more data, which is not always feasible. What if the data available to you was just observational data? And आपके पास और data नहीं है, and it's very expensive to collect more data. So what you do is you sample from your sample. There are a few things that you have to be very careful about. These three things you draw at random, आप randomly sample करते हैं from your sample. The second important thing is that you sample with replacement. The third important thing is that you have to sample as many values as the original sample contained. So अगर मेरे original sample में 1000 values थी और मैंने 200 bootstrap samples generate करने हैं तो हर sub sample के अंदर भी there must be exactly 1000 values, no more and no less. And obviously अगर 1000 में से मैं 1000 का sample लूंगी without replacement तो exactly वही चीज obtain होती जाएगी over and over again, which is why one of the keys to resampling is that you sample with replacement. So these are the three things that you take care of in bootstrap sampling. Why does bootstrap sampling work and when does it work? Let's recall uh, the law of averages that we looked at. Law of averages, law of large numbers. जितने ज़्यादा मेरे sample का size बड़ा होगा उतनी ज़्यादा my theoretical probability of an event will be close to the observed probability of the event that, well, I'm looking at. So bootstrap sampling works well when your original sample is large and representative enough. With that, let's come back over here. You have two very small samples over here, but that's because this problem has been adapted to fit on paper. So you conduct a bootstrap analysis. This is the data that is given to you. मैंने दोनों groups के अंदर samples को सिर्फ shuffle किया है and 0 1 2 0 1 2 over here I have generated three bootstrap samples for each category. And then मैंने bootstrap samples के लिए differences calculate कर लिए हैं. This is already given to you, which is okay because we've been over these things a couple of times. State the null and the alternative hypothesis for this experiment. The null hypothesis will be that background music does not impact student performance. The alternative will be that it does affect, or in this case, negatively affect exam performance. Then you compute the means of the original and the treatment group. I'm not going to do this right now. It's already been done for you. And quickly I will iterate. अभी तक हमने कोई statistical test run नहीं किया. There are three tests that are given to you in slides. So I will just show you these as well. ये tests कैसे conduct होते हैं, you don't need to know that at all at this level. You have a T test, a P test, and a Z test. P test we have been over in detail. This has been covered in class as well, a permutation test. परम्यूटेशन टेस्ट की कोई assumptions नहीं है. You can use it to compute any statistic of with whatever sample size is given to you. T test and Z test में एक key difference ये है कि sample size is typically less than 30 and you do a T test. If the sample size is large, greater than or equal to 30, you do a Z test. Another assumption is कि T test में your data must be normally distributed. Well, T and Z test में. But T test में you don't need to know the population standard deviation. You need to know that for a Z test. So anyway, they've asked you what test you will be using in this example. Since we have a sample size of only 5 available, so you will use a t-test plus unknown population standard deviation. We will not be testing this क्योंकि हमने इसको सिर्फ एक preliminary level के ऊपर cover किया है. This is very important though. A colleague suggests that the variance of the sample means for both groups appears too high. She proposes increasing the size of each bootstrap sample to address this issue. Do you agree with her approach? Provide proper reasoning for your answer. Since I've already iterated this, I will just tell you again that this is not valid because bootstrap sampling की ये requirement है that all your subsamples के sizes must be equal to the size of your original sample, meaning that she can not do this. That will actually be it from my side. Are there any questions?